Yeah, I'm starting again because there seems to be some problem with the sound. So on behalf of Smith & Zone, we kindly welcome all the participants in today's webinar. My name is Egbert Dikkers and I'm Global Director Sustainability for Smith & Zone. We are pleased that you are joining us today for part 1 in our series of 2, in which we focus on environmental sustainability. Today we will focus on understanding the basics of sustainability, and on October 11th we will focus on life cycle assessments. For those of you who do not know Smith & Zone, we are a 7th generation family-owned business fully dedicated towards developing and marketing innovative chemistry to create a sustainable leather that can meet the most strict material and physical characteristics. We are proud on the fact that on the occasion of our 200th anniversary this year, King Willem-Alexander of the Netherlands has granted Smith & Zone the royal predicate this summer. Our history is built on a continuous focus on the future. This is the main reason why we are focusing and organizing a series of webinars to share our knowledge and engage with the leather value chain for a better understanding of the role of leather in a circular and responsible society, and to understand and appreciate the role that chemistry can play in this. Sustainability is a complex topic, and as a chemical company we experience an increasing focus on sustainability and the need for supporting data. For example, how do you know if the chemistry that is prescribed by a brand or purchased by a leather manufacturer is the right chemistry that results in efficient and effective leather making processes with a minimal waste stream? It's because of this ever-growing request for sustainability information that Smith & Zone has set up targeted internal working groups like our LCA working group next to our internal wastewater working group. The purpose of these internal specialist groups is to understand the industry direction and create a Smith & Zone roadmap to ensure that we can maximize the support to the leather value chain. We also notice that brands are experiencing difficulties in understanding and positioning the value of leather as an ethical and sustainable material. We will briefly touch that in this webinar as well. Today's webinar has been set up as an entry-level explanation that is giving insights in environmental sustainability in the leather value chain. We expect that the content of this webinar will guide you in making responsible chemical and material sourcing decisions. This webinar is based on an earlier published frequently asked questions document that has been set up by Smith & Zone. And today, Dr. Yuji Ma, our senior scientist, will explain to you in more detail some of the topics that have been mentioned in that FAQ. And for those of you who did not yet download this FAQ, please feel free to do so from our website. As you know, sustainability is not only about the environment, but also about social matters and governance. Today, however, we will focus on environmental sustainability. At the end of this webinar, we will have time to answer your questions. And if your question has not been answered today, we will get in touch with you separately. I wish you all an interesting webinar, and I pass the presentation to Yuji. Yuji, please can you take it from here?
Thanks, Egbert, for the introduction, and thanks everybody who are now logged on to our platform. On the hot topic of environmental sustainability, there are so many words being used or misused nowadays, and our intention is to clarify their meaning in this session. Keywords and topics to help you understand environmental sustainability will include bio-based content, bio-based carbon content, biodegradability and compostability, circular economy and life cycle assessment, cradle to gate, cradle to grave, cradle to cradle, carbon footprint, and carbon offset. Today's audience, I see, is diverse, which is the reason why we will do a quick check on the existing understanding of some of the terminologies. In the next slide, we will share you 3 statements that are either true or false. Please take a minute and think about your answers to these questions. So the first question, longevity is a factor in determining the sustainability of a product. True or false? The second question, carbon footprint equals life cycle assessment. Is that true? The third question, biodegradability equals compostability. What do you think? So in this slide, we will show you the answers to these questions. So indeed, longevity is a factor in determining the sustainability of a product, but carbon footprint doesn't equal life cycle assessment, and biodegradability also doesn't equal compostability. And in the next slides, we will explain to you, hopefully, why. Now you know the answers to the earlier question, but in order to understand why, we will start this from the beginning. Where do materials come from? Here, we would like to begin with providing you an explanation on the terminologies related to the origin of materials. What is fossil-based materials? Fossil-based materials refer to materials made from fossil fuels, including petroleum, that is crude oil, coal, and natural gas. In contrast, what is biomass? Biomass is material of biological origin, excluding those embedded in geological formation or fossilized. And bio-based material refer to materials derived from biomass, and bio-based content refers to the fraction of a product derived from biomass. Leather is a bio-based material derived from a byproduct from the food industry. However, many chemicals used in the leather industry nowadays are still fossil-based. Our company and several others are devoted to make a difference in this respect by developing bio-based solutions for the leather industry. Nowadays, there are some leather alternatives consisting of either a bio-based substrate or a fossil-based substrate. It is very important to realize that some so-called plant-based alternatives, which are supposed to be bio-based or largely bio-based, actually consist more than 50% fossil-based materials, namely synthetic polymers such as polyurethanes as strengthening components. So in short, leather is a bio-based material that is processed with fossil-based and bio-based chemicals, and leather alternatives are bio-based or fossil-based materials processed with fossil-based or bio-based chemicals. We've just mentioned in the previous slide that leather is a bio-based material originating from a byproduct from the food industry. So what is a byproduct? Byproduct, by definition, refers to output other than the principal products of an industrial process. So here we are showing you two examples. In the left figure, you see the sawdust or wood chips generated in the processing of wood. And in the right side, you see the hide generated from food production. Unlike joint products, byproducts have low value in comparison with the principal products and may be discarded or sold either in their original state or after further processing, like the hides we show in this picture is actually processed a little bit. The hide or skin from animals, again, we stress that it is a byproduct from the food industry. I believe we are all very familiar with the phrase climate change, as it has almost become a daily topic nowadays. Climate change is associated with carbon emissions, which is also related to the origin of materials, such as the bio-based content of a material. With this slide and the next, we would like to give you a bit of in-depth explanation on the quantification of the bio-based carbon content and bio-based content of a material. In order to understand the quantification methods, let's start with an explanation on the different forms of carbon. Carbon has three different forms or variants, with over 99% of all carbon in the form of carbon-12, a stable form of carbon. Radiocarbon or carbon-14 only appears in trace amounts, which is constantly generated in the Earth's atmosphere and incorporated by living organisms through radioactive CO2. The interesting fact about carbon-14 is, as already indicated by the word radioactive, that it undergoes a slow decay. Its half-life, that is to say, the time required for an amount of carbon-14 to reduce to half of its original quantity, is about 6,000 years. This means that fossil-based materials formed over millions of years ago contain almost no carbon-14, and all the carbon-14 that can be measured in a material must come from relatively recently created radioactive CO2 through living organisms. The difference between bio-based content and bio-based carbon content, as the terms already suggest, lies in whether atoms other than the carbon has been taken into account of the calculations or measurements. This we will explain more in this slide. The bio-based carbon content is determined based on the so-called radiocarbon dating method. Radiocarbon dating can be carried out in a standardized way according to the ASTM 6866 or EN 16640 methods. With the standardized methods, the ratio of carbon-14 and carbon-12 can be determined by the so-called accelerator mass spectrometry, which indicates then the age of a material and the proportion of renewable organic carbon it contains. Having explained all this, we, as many others working in the chemical industry, also reckons the amount of resources, that means cash and manpower, needed to have all ingredients tested by the standardized carbon-14 methods. For those who have in-depth product knowledge, a mass balance method can also be applied to calculate the bio-based or renewable content of a material. A standardized way to do this has been described in the norm EN 16785/2. The mass balance method differentiates from the radiocarbon dating method in that it not only takes into account of the carbon atoms, but also other atoms such as oxygen, hydrogen, and nitrogen that are associated with the carbon atoms. Having explained then the starting point of or the origin of materials, let's talk about the other side of the material cycle, biodegradability or compostability. Those are associated with the end of life of a material. Biodegradability refers to the ability of materials to be broken down into simpler substrates by microorganisms such as bacteria or fungi. Biodegradation can happen under different conditions. For example, when oxygen is involved, the process is called aerobatic biodegradation, otherwise anaerobatic biodegradation. Degradation of a material can also happen in the absence of microorganisms, and this form of degradation is called abiotic degradation. It may refer to processes such as hydrolysis and oxidation. Biodegradability process passes through 3 stages, as shown here in this slide: biodeterioration, biodisintegration, and bioassimilation. We encounter the word compostability a lot. What is then meant by compostability? Compostability is biodegradability under specific conditions. It is the capacity of an organic material to be transformed into compost through the composting process. Compostability is a specific case of biodegradation process and mainly covers the first 2 stages of biodegradation. It is probably easier to understand the relationship of difference between biodegradability and compostability via the figure shown here. All compostable materials are biodegradable, but not all biodegradable materials are compostable. Luckily, by the time we are holding this webinar, our NARA tanning team has already explained this topic in more depth through a masterclass earlier this year and a white paper that can be downloaded for free. You are all invited to take a look at this great reference on this topic of broad interest these days. Is leather biodegradable? Is a much heard question. It's good to consider that the unique characteristics of leather include the fact that it is repairable, and can be used for a long time, to name only a few. Manufacturing leather means that the collagen is transformed in a way that it is no longer easily broken down and thus support longevity. It is also good to realize that leather is rich in carbon, nitrogen, and oxygen, the elements that are appreciated by bacteria and fungi. In the normal landfill, it will take mostly somewhere between 10 to 50 years for leather to biologically degrade. Leather is increasingly compared to alternative materials, often plant-based materials like those from apples, cactus, pineapple, or likes. These starting materials are renewable just like raw hides, but it is important to know that to make these materials usable and durable, they are often mixed with amounts sometimes up to 70% of polyurethane or having a polyurethane-derived coating. Here, it is good to realize that synthetic materials like polyethylene, PVC, or polypropylene take hundreds of years or sometimes more to biologically degrade. To answer to both of the questions listed here, whether be that biodegradable, can plant-based materials be biodegradable is yes. Leather and alternatives can be biodegradable. The major difference lies in the amount of time it takes for them to biodegrade. As we see today, leather generally degrades faster than alternative materials. Linking the origin of materials and their end of life, it's time for us to talk about life cycle assessment, or LCA in short. LCA is a methodological tool to quantitatively analyze the environmental impacts of products or services throughout their life cycle. LCA is carried out in a standardized way according to ISO standards 14040 and 14044. As for materials or products, it is starting from its origin until its end of life, which includes raw material extraction, manufacturing, packaging, processing, transportation or distribution, use, and final disposal. The illustration displayed on this slide shows the typical 6-stage product lifecycle model, sometimes 5 stages when you combine manufacturing and packaging, from cradle to grave. But LCA studies can also be carried out using other product lifecycle models, which will be explained later down this presentation. It might be easier to understand such a concept by the practical example of the life cycle of leather shoes. Leather shoes originate from raw materials from the hides and skins obtained from the byproducts of the food industry, starting from animal breeding. Hides are then transformed into leather crust and eventually finished leather. The leather making process involves the following steps: beam house, tanning, wet end, and finishing. The leather enters the shoe factory where shoes are made, where the shoes are packed and distributed via wholesale, retail, and finally to the consumer. The use of the product is also an important step in the life cycle. The longer the usage, the more sustainable a product can be. Here, leather shows one of its unique advantages of reusability or longevity. When shoes are worn out, they will still mostly be disposed through either landfill or maybe also a composting and recycling process. Increasingly, we see initiatives that start with the design of a consumer product, such as leather shoes, that has the potential of being disassembled. These disassembled products can then be used again as raw material inputs to enter a new life cycle of shoes, for example. We have used the previous slides explaining the whole life cycle of a leather shoe. Next to cradle to grave, that covers the entire life cycle of a product from raw materials acquisition, or the so-called cradle, all the way to its final disposal, or the so-called grave. Other product life cycle models include cradle to gate or cradle to cradle. Cradle to gate means partial product life cycle from cradle to factory gate. Cradle to cradle, on the other hand, can be viewed as a special type of cradle-to-grave, where the final disposal step is a valorization process, such as recycling. Recycling provides a material stream that can serve as new raw materials, which could be the start or the cradle of a new life cycle. When LCA is concerned, from cattle breeding to shoe factory would be viewed as cradle-to-gate. From cattle breeding to disposal of the shoes would be viewed as cradle-to-grave. And from cattle breeding to recycled parts of shoes re-entering a new life cycle would be viewed as cradle-to-cradle. To give you more examples on cradle-to-gate LCAs, we would like to use the stages of the leather making process to illustrate the different gates that can be involved. We are all very familiar with the leather supply chain as shown here, at least by now. Starting from livestock, cattle breeding, the animals will enter the slaughterhouse before the hides can be further processed in the beam house, entering the tanning stage, wet end stage, finishing stage, and eventually manufactured into consumer goods. In this whole process, depending on the business needs, there are quite some options to be defined as gates in the LCA studies. For example, it can be defined as the start of the tanning process, or when crust enters the finishing step, as well as when the finished leather enters the manufacturer's gate for consumer goods. In the slide showing different life cycle models, we've shown you a circular illustration of a cradle-to-cradle model. Nowadays, when we talk about environmental sustainability, a very often encountered word is circular. So what is circular in the context of a circular economy? A circular economy, as the name indicates, is an economic system different from the traditional linear model. A circular economic system operates with closed loops in which raw materials, components, and products lose their value as little as possible. It has three main principles: driven by design, eliminate waste and pollution, keep products and materials in use, and regenerate natural systems. A number of R's are related with these principles, including reuse, reduce, and recycle. Here, we would like to add a short description on the related phrase of post-consumer waste, which refers to the waste generated by consumers as part of a material stream. I guess this is rather easy to understand, especially in the context of a linear economy. We think probably a good way to explain this concept is to use the example of the recent design challenge that was organized by Smith & Son earlier this year. In this event, young designers were challenged to show their designs promoting the concept of sustainable fashion by focusing on timeless design that ages to perfection over time. In this slide, we show the project roots of one of the contestants, Javier. Roots reduces the distance between raw material process and manufacture for the final product, minimizing the environmental impact from the exceptional sustainable leather to the whole supply chain needed to develop the shoes. By combining a timeless design with a sustainable and repairable material that is leather, it enhances the product lifespan enormously. That refers to the longevity we have mentioned before. Furthermore, the leather used is chrome-free, heavy metal-free, and aldehyde-free, and therefore offers the possibility of being biodegradable and compostable. It could theoretically close the loop in a circular economy model. Of course, cradle to cradle is the most ambitious goal to achieve in this case when we talk about the three different life cycle models, but also the most difficult one. We need the whole leather value chain, including consumers, to work together on the cradle-to-cradle life cycle. The transformation to a cradle-to-cradle thinking asks for the participation of all value chain partners, as we just mentioned, including the consumers. For the leather industry, we are talking about designers, brands, tanneries, chemical companies, and eventually as consumers. For the designer, we think it's important to broaden your knowledge about materials and circular design principles, get yourself actively involved in sourcing, create the demand for sustainable materials throughout the value chain. For brands, especially for the sourcing manager, innovation managers, sustainability managers, please take a whole value chain approach to look at your brands or the products. Reach out to chain partners such as tanneries and chemical companies to explain your wish. For tanneries, I think it is important for the tannery owners and also the decision makers to look for strategic partners and the best available chemistry to meet your need. For chemical companies, I think they should be innovating in bio-based, metal-free, chrome-free alternatives, and also being transparent and getting involved in LCA thinking. For consumers, our recommendation would be to buy responsibly, buy less, and use your product longer. Try to repair and recycle. By now, we have explained that LCA is a standardized way to assess environmental sustainability. Through this tool, we can also obtain some quantitative data, such as carbon footprint. Let's start with looking at what is carbon footprint. The important topic of carbon footprint is sometimes less accurately referred to as CO2 emissions. It will be repeated in more detail in our second webinar focusing on life cycle assessment, which is to take place on October the 11th. But since it is so frequently and widely discussed, we find it necessary to briefly cover some basics here. Carbon footprint or carbon profile is defined as the overall amount of emissions of carbon dioxide and other greenhouse gases, including methane, nitrous oxide, chlorocarbons, hydrochlorocarbons, and other associated with a product throughout its life cycle. Having referred to a product here, it has also much broader meaning that not only is restricted to the association with a product, but also can be with an individual, an event, such as a festival, an organization, a service, etc. The definition clearly tells you that the contribution of all greenhouse gases, thus not only carbon dioxide, should be considered. In practice, the emissions of various greenhouse gases are converted to the equivalent amount of carbon dioxide with the same global warming potential, or GWP, and reported. Carbon footprint is the footprint of all greenhouse gases, and thus much more than CO2 footprint. And carbon footprint does not equal to LCA. Carbon footprint can be mitigated in two ways. Generally, either by reducing the contributing factors in a product life cycle or to utilize the concept of carbon offset. Carbon offset is a measure to compensate CO2 emissions or its equivalents made elsewhere so that the net emissions can be kept in balance. To give you a practical example, nowadays many houses are equipped with solar panels. On a sunny day when the electricity produced by solar panels exceeds the amount of electricity consumed by the household, the extra energy can then be used to offset the CO2 emissions made by, for example, an oil refinery. Until now, we have been focusing on the topic of reducing the environmental impact by understanding and improving the chemistry that is being used and how this will influence the LCA of a final product's life cycle. We want to stress that reducing a product's environmental impact is not only about choosing the right chemicals with the lowest possible footprint, it's also about starting with the best substrate that has the potential to biodegrade easily and also support a long-lasting life, or in other words, to reduce the impacts on usage and disposal. Longevity is a very unique feature associated with leather products. Longevity refers to the relative long lifespan of a product or a material without compromising on its physical and aesthetic characteristics. In the circular economy model, it is of high importance to take the longevity of materials into account already in the design phase. And this longevity, the durability, is one of the things we love about leather. Leather can stand wear and tear, and it ages beautifully. In these two pictures, you can see the difference of an aviation leather that was given to us by the courtesy of a major tannery involved in aviation leather making. On the left picture, you see a leather seating from an aviation seat in service for already 9 years. In contrast to the right picture, where you see synthetic seat from an airplane that has been in service for only 3 years. This huge difference in longevity is also challenging for chemical companies as they need to ensure that they develop solutions with the lowest possible environmental impact, but still meet the very demanding requirements for long-term usage. In order to make better decisions for a circular and responsible society, it will be crucial that together we are obtaining more data on the longevity of a product until the moment a consumer is disposing it. Now, having given you a long list of keywords and their explanations, we will get back to practice. All the words we've explained so far related to your question on how to make responsible chemical and material sourcing decisions. To ensure that you are working with the best available chemistry or chemical suppliers, we recommend you to go through the checklist shown on this slide when you are facing such a decision. First of all, you should identify chemical partners that can meet your company's requirements and fit with your own strategy. Secondly, you might ask for data availability, such as the bio-based content or renewability content of the chemicals, or check what other supportive data a chemical supplier can make available, supporting your decision-making process, including getting a better understanding of the effect of chemicals on the waste stream. And thirdly, you might request what level of ZDHC conformance can be demonstrated. This will mostly support you ensuring that you are able to manufacture leather that meets chemical restrictions and is in conformance of those brands that are connected to the ZDHC organization. When faced with leather sourcing, our recommendations are listed here. First of all, which type of leather you are working with and what is your goal? For example, is having a high bio-based content very important to the end user? We know that leather has the natural advantage of being a bio-based material. And by now, we also know that by carefully choosing the wet end and finishing products, we can truly maximize its bio-based content. For some people, compostability might be an important goal for a specific product line. If this is the case, the quality of the compost is just as important as the compostability of the material itself. Making sure that less or no heavy metal and other harmful chemicals will enter the compost requires a careful choice of the processing chemicals as well. You might want to lower the carbon footprint of your final product. Do you have the carbon footprint data of your suppliers available, as well as those from your own manufacturing process? There are often data available for certain groups of chemicals, for example, phenolic synthanes or fish oil-based fat liquors from a database. You would like to reduce your wastewater treatment load. Is your supplier knowledgeable enough to give you the right inputs if necessary? For some, environmental certifications are required. The keywords explained here are not only essential for the proper understanding of environmental requirements, they can also guide you in making the right choice for the right type of certification, given that many are quite related. And finally, we think that from a leather sourcing perspective, it is important to try to learn from each other. In other words, it is advisable to consider which partners in the leather value chain can help you to build the story of sustainable leather to your final consumer. How can, for example, a leather chemical company or a leather manufacturer support you in translating all the good things they do to understandable consumer language? As a general source of information to learn more about leather, we kindly refer you to the website of Leather Naturally for more information. Now we come almost to the end of what we would like to present today. And here is your key takeaways of today. Leather is a bio-based material with a high bio-based content. I hope you have learned it or remembered it by now. The chemicals used in manufacturing of leather also influences the biodegradability of the material, not only leather. By making leather a waste product, the hide is being recycled. Leather fits into a circular economy model. Different product lifecycle models can be used to perform an LCA study. And in order to meet your sustainability goal, you can do the following. First, asking the right sourcing questions, the origin of chemicals used, for example. Secondly, checking certifications, LWG, ZDHC, do you need them? Thirdly, looking at the longevity and end of life of products. So with this, I would like to end my presentation and hand over my words to Egbert, and we are ready to take your questions.
Yeah, thank you very much, Yuji, for guiding us in understanding the basics of sustainability. And during the registration for this webinar, you had the opportunity to raise your questions, and also now we see that some questions come in. So we have a few minutes to answer some of the questions, and the other questions we will get back to you. I think one of the questions which was asked, will we receive this presentation? Yes, we will ensure that you will receive this presentation. One other question is, Yuji, I would give that one to you. Did you perform C14 tests on alternative materials?
Yeah, thanks for the question. I think we can give a very simple answer. We haven't done that yet because our current focus is C14 on our own products, our own product portfolio, as well as our leather collections. So we are working on two lines. One is to understand how to improve the bio-based content of our own products. So we are working on the C14 data collection on our products. And the second one is that we are looking more and more at a bio-based leather article concept. So to that end, we are also working on bio-based leather articles. So right now, the C14 measurements we focus on these two areas, not yet on alternative materials. And as I have already mentioned in my presentation, there are a lot of so-called plant-based materials right now, but sometimes they can contain up to 40%, 70% actually of petrol-based polymers, such as polyurethanes. So we expect that with C14, you will be able to see these results very clearly.
Yeah, thank you very much. Then there was another question. What can we do for more green environment, and which precautions should we take for sustainable life? What are the tips on how to lessen our impact on nature? How can we transform the environment we live in? Yuji, can you take that one?
Yeah, sure. So I think we more or less also have touched on this question during the webinar. I think a simple answer would be to be choiceful in everything you do. Think about environment, think about environmental sustainability. This can be, for example, save energy at home, choose renewable energy sources, get your solar panel installed, consider to leave your car at home whenever possible, reduce and recycle, become a responsible consumer by buying less, buying higher quality with longevity in mind, and avoid the use of plastic bags, etc.
Thank you. Then there is a question, what's the most effective way to convince your company to spend money to prioritize sustainable options? I will take that one. It's a very good question. And I think it will also very much depend on the DNA of your company. In other words, it will depend on, do you want to spend money because your customer is asking urgently for information, or do you already start earlier because you are convinced that you need to have a better understanding of sustainability in your own supply chain? Yeah, I can say that here within Smith & Zone, we are issuing an annual CSR report since 2014. And for us, it's a critical thing which is in our DNA. But I think it will really depend on your own company and on your own market in how far you're going to be involved in this topic. Then there is another question, and I will leave that also as the last question because we scheduled this webinar until 3:45. Yuji, can switching to sustainable materials allow us to continue consuming current rates or similar?
To address this question, I think we cannot forget that the world population is growing and it will continue to grow. And UN has an estimation that the total of the world population will reach close to 10 billion actually in 2050. That's roughly 25% more than our current situation, although the general annual growth rate is and will continue to slow down in the coming decades. We believe that switching to sustainable materials will help us to fight the source scarcity problem in general, because the word sustainable implies to maintain at a certain rate or level. However, don't forget that we consume many different resources, and it would be logical to look into area-specific consumption rates, such as oil consumption or energy consumption. I think I will leave it at that.
Yeah, thank you very much. I think we are going to close it. So should you have any further questions in the next couple of days, then please do not hesitate to reach out to us. We have seen several questions coming in. Not all questions have been answered. We will get back to you on your questions. We will do that individually. Furthermore, we draw your attention to the second webinar that we will organize on October 11th. And in that webinar, we will dive deeper into life cycle assessments, a current hot topic. And next to Dr. Yuji Ma, we will have two guest speakers, of which is Fernando Bellesi of Prime Asia and Federico Brugnoli from Spin 360. And these three experts will explain what an LCA is, how it can be used in decision making and improvement projects, and what are the pitfalls in interpreting, because that's a really important thing what we experience ourselves as well. For now, we are confident that you had an interesting webinar. We thank you very much for your interest and we wish you a good rest of the day. And we hope to see you back on October 11. Thank you very much.